Hey guys! Right now we're reviewing over every important thing, every unit we've gone over this entire year in preparation for our final exam at the end of May. And we're doing that in our math class. If you wanted to be a bit more specific about where we're reviewing, you could say we're at Mrs. Aller's classroom at B116. And if you wanted to be extremely precise, you could say that we're reviewing at 32 degrees, 55 minutes, 26 seconds north, 80 degrees, 13 minutes, and 55 seconds west. That is our exact location right now, and we found it by using coordinates. Coordinates have been used for centuries for finding location and position, and have become a pretty useful tool in math. Now, typically we're used to seeing coordinates placed on a Cartesian plane, in which basic x and y values are used to plot a point. So if I were to give you the point, I don't know, 3, 5, you would know that that meant that there was a positive x value of 3 and a positive y value of 5, and the point would go around right here. And because this is a Cartesian coordinate, they're referred to as rectangular coordinates because they move in a box-like shape. So remember this here, square-like box. Now, polar coordinates are just another way to find the exact same point in space, but rather than using x and y values, we use the distance of the radius and the angle measure. To put that in perspective, if I were to plot the point xy like I just have, the radius would be the distance from that point to the origin, and that would be represented by r. And the angle would be the degree or radian measure between those two lines, represented by theta. The equivalent way to describe this point would be to write r, theta, just like that. Awesome. Looking at this setup, and using basic knowledge of properties of right triangles, you can determine the equation to convert between both polar and rectangular coordinates. X would equal r cosine theta, and y would equal r sine theta. And we can get these from our understanding of SOHCAHTOA. If you are given the r and theta values, you can easily plug them into this equation to find the rectangular coordinates. We also have that r equals the square root of x squared plus y squared, which is just the Pythagorean theorem if you think about it. And the theta value, which I did a very poor job of including in this screen, but I will tell you right now, is the inverse tangent of y over x. And you'll see that in about just a second. And there you go, right there at the bottom left. Alright, so if I gave you the rectangular coordinates of a point as 6, 9, then this would be how you would find the equivalent polar coordinate. Plugging in r equals to x squared plus y squared, which is 6 squared plus 9 squared, which simplifies to 36 plus 81. And ultimately equals the square root of 117. To find the theta value, you just easily plug in the inverse tangent of the y over the x value, which is 9 over 6. And I'm not going to spend time doing that, so I pull out the calculator and I find, whoa, look at that! You get 56.3099. And that is your angle in this scenario. And if you just want to box your answers, that is always a great idea. And here is the final way it will look in the new polar coordinates, with the r value followed by the theta value. Look at that. So now I'm going to give you a polar coordinate, that is the square root of 65 as the r value, and 54 degrees as the theta value. And this is how you'd find it in rectangular form. As we know, as you look at the bottom left, x equals r cosine theta. So x would equal the square root of 65 cosine times 54 degrees. And make sure your calculators are in degrees depending on what the theta value is. And of course, y would equal the square root of 65 sine 54 degrees. And because I'm a slacker, I like to use my calculator and get those values right there. So all you have to do right here is, first of all, get your camera clear, and then put in those values, because you're smart, you're independent, and you know how to math. And you get these values right here, and they should be correct. And if you wanted to plot that point as a rectangular value, it would be about right there. And it's r value, as we know, the distance, the radius, that would be the square root of 65, as it should be, and the theta value should be 54 degrees. So now they have a better understanding of what needs to be done, try and find the complementary coordinates for these coordinates. And just because I love you guys, I gave you the equations, and I hope you can solve this within the allotted time that we have. And here you go, these are the answers. You must be smart if you got these, and if not, there's no problem, you just gotta keep trying. Now you might have noticed with these problems especially that you might have got a different angle measure, and that is because, you might be remembering this now, on a calculator, this is the graph of the Pythagorean theorem, the unit circle. And remember that the positive values and the negative values, these are the only sides of the unit cycle it will actually account for. That left side, it will not count for. So what you have to do is, even though your point might look like it's down there, you have to add 180 or add pi to get it into the correct location. Because remember, you can have a negative x value or a positive y to change the entire setup, or both negative x and negative y to make it look like it's a positive in quadrant 1. And remember, always remember the coordinates of the point. If it's in quadrant 3, remember that it's in quadrant 3, and that you'll have to add 180 degrees or pi, because that will completely change your answer and will give you a failing grade. And none of you are failures, we're all winners. So guess what? You're gonna do this, because I believe in you. One more important thing to know, and you might have already remembered this, is that aside from the components used to find a specific point, there's something else that is different between a rectangular and polar coordinates. Now, to demonstrate this, let's look at this point right here. Now, I want you to tell me what this point is. Just scream it at the top of your lungs in this class. No one cares, no one's looking, just, okay, yeah, I'm putting it down. It's 6, 5. But are there any other coordinates to signify this point right here? The answer is no, because this set of points is the only set of points that describes this location on the Cartesian graph. But you can with polar coordinates. In fact, you can write an infinite amount of sets for a single point because of coterminal angles. But to keep it simple, let's just keep it to 4. Now, we can just pull out our handy dandy polar coordinate graphing paper and plot the point 5 pi over 6 right here. And that point will go right around there. There you go. And we need to realize that the radian measure is positive because it goes counterclockwise from the 0. And that there can also be negative radian measures that go clockwise from 0 to give us the point 5 negative 7 pi over 6. Now we also need to remember that there can be a negative radius, and that just puts us completely across the diameter of the unit circle into the point we need it to be. So we need to find a point that is 180 degrees or a pi measure across from the point we need. So if we wanted to do this positively, we can just look around the unit circle, and we can see that 11 pi over 6 is completely a pi measure across from where we need to go. So a negative 5 and 11 pi over 6 would put us in the exact same position. We can also do this for a negative radian measure with the same negative radius. And to do this, we can simply go down pi over 6, a negative pi over 6. So we have negative 5 pi over 6, and we have the exact same point for each one of those coordinates. And it's amazing, because of these coterminal angles, we can have an infinite amount of these. So now if I were to plot a point somewhere around right here, I want you to give me 4 coordinates for this single point. Alright, now that we're back, you should have gotten the first one, because it's pretty much the simplest one. You have the radius of 3, and you have the radian measure of pi over 3. I'm going to separate it right there so we know which we're talking about right now. Now for our other one, remember we can go negatively around the unit circle, going clockwise, and we can get a negative radian measure, and you'll see in a bit, because I'm klutz, I didn't want to include it in this section, we'll get 3, negative 5 pi over 3, which gives us, again, the same exact point. Remember, our negative radius, we just have to go 180 degrees, or pi, across the unit circle to give us that point. So a negative 3, 4 pi over 3, will give us the same point, because we're going across the unit circle like that from the point that is completely across from it. And remember, a negative radian measure and a negative radius measure will give us negative 3, negative 2 pi over 3. And there you go. Those are 4 easy steps, 4 easy coordinates to give you the exact same point. Alright guys, you did a great job at listening to this review. I wish you the best of luck when you take this exam. You are going to destroy it, and you are going to show it who its maker is. Mrs. Allers, because she's going to grade it. Love ya!